Alrighty, today we're going to do 1.4 lesson, which is solving equations. I'm hoping this is an easy lesson, but please do take the time to review and make sure that we remember how to solve equations because they're going to continue to show up throughout the entire school year. So for this first one, I started easy. It's x plus 4 equals negative 12. I want us to solve for the variable x. Notice how they are adding 4, so to undo that, to get the variable by itself, we are going to subtract 4 on both sides. So if we subtract 4 on both sides, we end up with x equals negative 16. Make sure for an equation, anytime that you want to check your answer, if you're unsure with it, just plug in the negative 16 back into your variable. So negative 16 plus 4 is negative 12. Both sides equal the same, so we know for sure we have the correct answer. Alrighty, number 2, we have 12b equals 18. Notice how they are multiplying on this one. So to undo that, we are going to be dividing. So we divide both sides by 12. Notice the 12s then are going to cancel out. So we get b by itself, and then over here on the right-hand side, we have 18 divided by 12. If you can reduce your answer anytime, you want to make sure that you do that before you leave it as your final answer. So I have b equals 18 divided by 12. They both can be divided by 2, so if I divide the top by 2, I get 9, divide the bottom by 2, I get 6. Notice a 3 goes into both of those still, so I can reduce it further. So divide the top by 3, I get 3, divide the bottom by 3, I get 2. If you would have noticed that 18 and 12, 6 goes into both of them, you could have skipped this in between and just took 18 divided by 6 is 3, and 12 divided by 6 to get the 2. Alrighty, the next problem, number 3, is negative 27 plus 6y equals 3 times y minus 3. Notice how I have parentheses, so I'm going to want to do the distributive property, distribute this 3 to everything inside of parentheses. So 3 times y is 3y, 3 times negative 3 is negative 9. Over here on the left-hand side, I just brought down our terms. Now the next step, I'm going to want to get the y's on one side and the numbers on the other side. So to do that, I always like to have my variables be positive, so I'm going to move the smaller number. So 3y is smaller, so I'm going to move that over. It's positive, so I'm going to subtract 3y on both sides. These then cancel out. So 6y minus 3y just gives me 3y. And then from here, since I move the variables to the left, I'm going to move my numbers to the opposite side, so to the right. It's a negative 27, so I'm going to add 27 to both sides. These 27s cancel out, so I get 3y equals 18. They're multiplying, so to undo that, I'm going to have to divide both sides by 3. Those 3's cancel out, so I then get y equals 6. Alrighty, this next problem, we need to solve for x. Notice that there's parentheses, so I want to distribute this 3 here. I want to distribute this negative 2 over here. So 3 times 2x is 6x. 3 times negative 1 is negative 3. Then negative 2 times 3x is negative 6x. Negative 2 times 4 is negative 8. And then I'm just going to bring down that 11x. From here, before I go any further, I'm going to combine like terms on my left-hand side. So 6x minus 6x, those are opposites, so they just cancel out. And negative 3 minus 8 then is negative 11. So then I have a negative 11 equals 11x. I'm multiplying over here. I need to get that x by itself, so I'm going to undo that by dividing both sides by 11. These 11s just cancel out then, so I get x equals, and then negative 11 divided by 11 is negative 1. Alrighty, now these next problems are going to look very similar, however the answers are going to look slightly different because they're going to, they could have a solution or it could be no solution or identities. So we're going to take a look what those types of problems are going to look like. So for this first one, it says 11 plus 3x minus 7 equals 6x plus 5 minus 3x. Is the equation always, sometimes, or never true? So I'm going to go through and solve it just the exact same way as the above problems that we went through. So my first step, I'm combining like terms. So 11 minus 7 is 4. I just brought down that 3x. 6x minus 3x is 3x, and then just brought down that 5. Then I need to get my x's on one side, my numbers on the other side. So if I subtract 3x on both sides, notice how they cancel out on both sides. So then I'm left with 4 equals 5, which 4 does not equal 5, so it's going to be no solution. So when the variables cancel out on both sides do not equal the same, it's no solution. So when it asks, is the equation always, sometimes, or never true, it's going to be never true. There's no number that will make this equation work out. Alrighty, let's try another problem. This is second example. When you're writing it down, we want to do the same thing. Is it always, sometimes, or never true? So we're going to start off with combining like terms. So 6x minus 2x is 4x. And then over here on the right hand side, 4 and the 1 are like terms, so that would give us 5. Then if we keep solving, we're going to get the variables on the same side. So this 4x, we're going to move it over, minus 4x, minus 4x. Notice it cancels out again, but then we're left with 5 equals 5. Then the last problem, both of the variables canceled out, and what was left over didn't equal one another, so it was no solution. This one, both sides do equal one another, so it's identity. So this one, it's always true. What always true means is that every single number that you plug into this equation is going to work out. It doesn't matter if you plug in a fraction, a decimal, or a whole number, it will work. Alright, the last example, we have 7x plus 6 minus 4x equals 12 plus 3x minus 8. So when I go through and I start solving, again, I'm going to start by combining like terms, just making it look a little bit easier to work with. So 7x minus 4x is 3x. 12 minus 8, I get 4. So 3x plus 6 equals 3x plus 4. Then I combine my 3x's, so minus 3x, they cancel it out again, both sides. Since they do cancel out on both sides, we know it's either going to be no solution or identity. We have to see if both sides are equal or not. The 6 does not equal 4, so both sides do not equal, so it is no solution. Alrighty, the last type of example that I would like to go through in this solving equations section is solving literal equations. This first equation, you might have noticed it from science class. It's using Celsius and Fahrenheit, so anytime that you want to go back and forth between the two. So it's C equals 5/9 times F minus 32, and it says solve for F. Notice we could distribute this 5/9, but if we're going to do that, we're going to have to work with fractions. So anytime that there's a fraction out front like this and you don't want to distribute that fraction, another way to get rid of it is to multiply both sides by its reciprocal. So the reciprocal, we just switch the 5 and the 9, so it would be 9/5. So if I multiply this side by 5/9 and I multiply this side by 5/9, what's going to happen, these fractions on this right hand side are just going to cancel it out, making it look a lot nicer. So on the left hand side, I'm going to have 9/5 times C, which is 9/5 C. And then over here, the 9/5 and the 5/9, those just cancel out. So we get F minus 32. And then from here, we still need to get the F by itself. They're subtracting, so we're going to add on both sides by 32. These 32's cancel out, so we're going to have the F by itself. So F equals 9/5 C plus 32. Alrighty, now this next one is S equals 3F minus 24. We want to get the F again by itself. So we're going to start moving everything over to the other side. They're subtracting 24, so we're going to add 24 to both sides. So those cancel out. So we have 3F equals S plus 24. They're multiplying by 3. We want to get that F by itself, so we need to undo it by dividing both sides by 3. These 3's cancel out, so we get F equals S plus 24 divided by 3. You can leave it like that, or you can divide both of these numbers by 3. So S divided by 3, or 1/3 S, and then 24 divided by 3, which is 8. So either answer would be acceptable.